Thank you, everybody, for joining. Juan, Sandeep, glad to have you here. What I want to do is kind of focus on a few things that I think it's important for us to know, especially as we spend more and more of our time building these incredible engineering projects. Um, Most people who are here in the morning found this out, but today, to the date, was 10 years ago, is when the first commit to IPFS got published.
Yeah,
10
I
years.
found that out.
We all found that out. Today was the day. Reflecting on that decade, did you think this is how far we would come along?
Oh man, this is not quite the answer you were hoping for, but yes. I didn't know how it was going to happen, but it was pretty clear to me that something like IPFS needed to exist, and that it was a pretty important construction. The commit itself says big things have small beginnings, and that was because I sort of expected this thing to eventually grow into something very significant. So sometimes you have the foresight to be able to tell whether something will grow, but you don't know how it will grow. It'll grow in very different ways in different communities. What I didn't expect was that the community that was going to adopt IPFS the most was going to be the blockchain space. That I did not predict. I expected IPFS to be much more adopted by other communities and like developer tooling and so on.
That one actually surprises me too. I thought it would be specifically to our space. I think a big theme that I want to kind of spend time on here is effectively understanding how our thinking has evolved in engineering these systems. 10 years ago, what we thought would be the case, or in your case, 7 years ago when Matic was kind of getting started, we didn't really expect a lot of these things to come out the way they are. We didn't have the terminology, like L2s didn't exist as a term, neither the sidechains, and everything in between. So my first kind of question to both of you is, how do you feel about where we are now from the way we've designed our blockchains today versus kind of how we thought they would be designed 5 years ago?
I think we all started with, like, first of all, I feel that for blockchains, specifically for the end user, consumer applications on blockchain, we have just finished the POC for that. There's nothing production grade for like millions of customers, something that billions of customers can use has not been built. But as you asked, like how blockchains were built previously and how they will be built going from here, is that the blockchain space started with BTC, where the decentralization, because you wanted to build an unstoppable money, censorship resistance, and all and decentralization were the most important thing. And then, since then, decentralization has been a core concept of whatever has been discussed with about blockchains. But when the industry came to applications, then people started digging in. And today, I feel that actually decentralization is a means to achieve few things. It's not that's why this rhetoric keeps on coming back that you
It's
see
not the
people
end
saying
game.
decentralization doesn't, the users don't care, because users don't care about decentralization. Users will care about few things though. User care about self custody. User care about this trustless compute. There is some level of care about censorship resistance from the users. And when I say by users, I don't mean to say 100% of the users. Every application has that 1990 concept. 1% of are the hardcore users who are true believers of all the ethos. 9% of them interact with those ethos, and 90% would simply use because others are there. So coming back to that these people consider these three characteristics as the most important characteristics, like trustless compute, self-custody, and censorship resistance to some extent. And now you realize that decentralization is a means to achieve these three. But actually, now with zero-knowledge technology, let's say, with zero-knowledge roll-ups and all that, where you can have a large computation elsewhere and then prove it on a more decentralized layer, especially with these layer twos, you can achieve trustless compute, self-custody, and some level of censorship resistance with forced compute without decentralization, right? And suddenly you see that, okay, now there is a case that a large number of enterprises also can use it. Large number of games which previously we always used to think that how any game will be able to do millions of transactions with multiple nodes which are geographically decentralized and all that. It didn't look possible. Now you can have a fully trustless system. I don't even call them chains. They are like trustless servers for me. And now I feel that trustless revolution is bigger than the decentralization revolution. And for me, going forward, it will be more and more about trustless. How do you build this trustless world? Decentralization will be a core part for layer one, where you need unstoppable decentralization and all that. But you can piggyback on this and create high volume, high transaction execution environments without having the decentralization also. So I see that there will be a gradient. You will have few public chains, highly decentralized. Even on layer two, they will need to be decentralized. And then you'll have a large number of application chains which will act centralized.
I mean, logically, it makes total sense, and we're kind of seeing that move anyway because that's kind of right now the immediate way to get that demand satisfied. Juan, I know you kind of officially started Filecoin as like a very large kind of central point for the data to be there, but as we kind of seen the evolution of FEM and a few other things that you've been working on, how has your thinking changed? Anything you want to contrast with what Sandeep said?
No, I think we agree on a lot of things, and I agree on the pathway that this is going to take. I mean, I don't know that, like maybe I think that I would disagree with is, I don't think that thinking of it as trustless servers is not decentralized. I think that is what decentralization is trying to get to, is like you're trying to create a structure where you don't have to trust the party to continue to honor a contract. You don't have to trust the party to not do something bad. You can verify it with the math and with the cryptography. And so I think it's definitely not decentralized logically in terms of the large scale number of nodes and so on. You don't need 10,000 validators to prove that a certain program was run correctly. You can absolutely do it in ZK, and that's I think where we heavily agreed. And so I think we have very similar visions of where this is going to go. In Filecoin specifically and with FEM, our pathway has been twofold. One part is we have this concept that data has gravity, where it's difficult to move around large amounts of data to different locations. So by creating a network and a system that is able to bring together an enormous amount of data for large-scale applications, once you go through that step once, and you bring it to one location, it is difficult to then move it again to some other place. So by creating an environment that is good for large data-intensive places, you make it much more likely that lots of software and lots of applications will come to that environment. Now that just shouldn't be one single chain. You want an environment to be highly scalable. You want the trustless servers as well to then bring that computation to that environment. And so we've been building Filecoin as a network and a chain that is supposed to be connected to everybody else. Filecoin is an L1, but only because of the we thought we were gonna need like 80. When we calculated it out, we were gonna need like 80% of the Ethereum block space. And so initially, our initial plan was we were gonna be one of the first Ethereum L2s, way before L2s were a thing. We were like a virtual chain. That's what we called it. And then Ethereum was gonna, we were gonna need like 80% of the block space, so we had to make an L1 out of that. But it's only like an implementation detail. From my perspective, what you want is you want sovereignty in networks, and you want high throughput. And it doesn't matter whether you're in L1 or L2 or whatever. It's really about what computation you're doing, what applications you're serving, and whatnot. And you need seamlessness in how you compute between these contexts, right? So we've built Filecoin as a network that is meant to be highly collaborative with every other network. You never see Filecoin being argued in the L1 debates at all. People don't even know most of the time that it's that. And that's by design. It's like you want Filecoin to be a friend to all networks and to be supporting whatever platform. It's not meant to, and for that, FEM is a really key component because of the hypervisor structure. So we want to enable lots of different VMs to be slotted on top of FEM to then promote this like high interoperability between pieces. So I don't know.
I'm personally seeing a lot of parallelism here with just kind of how the internet works right now. It's just how we have different ways of cloud computing, and effectively we're talking about different sort of hierarchy of what being modular is. You are a big proponent of modularization in blockchains. I'm seeing a lot of examples here of how that is designed to be leveraging a lot of the ways others are designing their blockchains. How do you think about monolithic versus modular?
If you are thinking long enough term, you realize that any kind of monolithic architecture, where like by monolithic architecture, you mean like one single chain, a lot of like alt layer ones have tried that, like one single chain, and they say that this chain will have like 10,000 TPS, 20, 50, even if it's like 1 million TPS. Will it ever be able to serve the whole world's like Web3 if the whole world moves towards Web3?
No.
Absolutely not, right? So no matter what kind of TPS you can create, you won't be able to. Like we were just discussing on stage, right? Like, do you see AWS and Google Cloud saying that, oh, we have 100 million TPS? No, they don't even say we have 10,000 servers, because this has to be infinitely growing. More apps, more digital things, like you need to be able to scale that. And that is what, like, I feel is the right kind of architecture. Even if you see internet also, in the internet you have these transcontinental underwater, undersea, cables. They connect like large continents, and then within continents you will have like broadbands and different kinds of technology. But all of those technologies, all of this bandwidth, commonly connected by a simple protocol called TCP/IP, right? And then everything is then interoperable with each other. I think for the trustless compute, that technology is ZK. Eventually, like the aggregation of ZK proof is going to become, or going to look like that TCP/IP of the current internet. And you will have these millions and millions of execution environments, the way today you have application servers for every mobile app, web app, whatever have you. And they all interconnect with each other in whatever way. If they want to, they have RPC protocols and all that. Everything built on top of TCP/IP. And I think that's why, like, we have a lot of builders also in the space. I think like there is going to be a very big opportunity for all of you guys to build these middleware protocols, where you have these multiple trustless environments proving, or kind of being proven on a single layer, let's say settlement layer, Ethereum in this case. And then, but you need a lot of these middlewares to, kind of these chains to collaborate with each other, indexing data, where you are indexing data for multiple chains, or on demand you are providing the index data. You want to have atomic transactions. There's just too much on that space. Intent-based transactions. Let's say I'm playing a game on a gaming chain, and I want to swap my game tokens to USDC on a public chain. I just should be able to have a, intent, given over there, and then you use this intermediate trustless provability using ZK and have this cross-chain transaction bring me back my dollars on the same chain. So these kind of protocols, some of them will become like really big middlewares, I feel. And this is how I think like this internet is going to grow, where you will have millions and millions of these chains. I think Filecoin is also building something similar with the DA and that tree structure of chains. I think that absolutely we truly believe in that also. And I see a lot of smart people, they think that the Web3 going big mass scale or global scale will need something like that. And we are also at Polygon trying to build something similar.
Yeah, no, I think this is interesting. Maybe Juan, this would be a good time to for us to learn about Sashimi.
So Sashimi is a project that's trying to bridge some of the like utility of Filecoin and the Filecoin network in terms of a great place to accumulate lots of data and store it and so on, and solve the concrete data availability problem for blockchains. So previously people were like, oh, well, you want this data availability thing solved in blockchains, why can't you just use Filecoin? And it's because you can, but you need to solve a particular set of constraints around when the data is available, with what provable guarantees and so on. So Sashimi is kind of an adapter there to enable any blockchain to be able to have a DA layer just for that chain, but then have long-term archival and storage in Filecoin to be able to seamlessly expand to large scale storage. So,
and I can also kind of tell people like how they can use, like today Polygon CDK and the DA layer of, let's say, Filecoin, is that you can launch a, let's say, single sequencer ZK rollup, which is connected to Ethereum using like Polygon's aggregated layer. The first version of that aggregation layer goes live somewhere in January, which is a slower version, which does the aggregation on Ethereum itself. And then there is a faster aggregation layer, which will become a layer on top of it. But you can use CDK to launch like as many chains as you want. And then because these are single sequencer chains, and with ZK, the provability is guaranteed. But only one scenario is there, where where the user needs the data, and there is a
Yeah, you want to be able
answer
to
from a
verify,
vendor,
and
you need to verify. So for extreme scenarios where you need to have the full security of the assets, the single sequencer can never steal the user's funds, even if the data is not shared anywhere. But sometimes if this particular sequencer goes down and user want to withdraw their asset to Ethereum, they need the data. So for those kind of places, all of these chains will need a reliable data availability engine where you can use like Sashimi and other data availability solutions. But I think that's a great way. Like if somebody is building something like that, I think that should
And
be
huge
very good.
plug for a lot of the groups building DA layers right now. Like Celestia's doing a great job solving a bunch of problems for a lot of groups. There's a number of other.
Eigendia and a few others.
Yeah, it's a really cool moment where a ton of innovation is happening. I wouldn't get it too hung up on any one technical solution now. From my perspective, we're inventing a lot of new constructions and coming up with lots of new kind of problems. You should expect the entire stack to be reshuffled and reframed a lot for the next 5+ years as we get into the applications with billions of users and massive scale throughputs. At that point, you can then think of the primitives as maybe starting to solidify. But for now, you should just expect that a lot of things are going to constantly be changing. Like you were talking about ZK, like as soon as you have zero-knowledge proofs in large scale for running a lot of programs, tons of the things that people want to use a full decentralized blockchain for is no longer needed. You can run it in a small program and then aggregate the results into a large chain. And so something like you should continue to expect the architectures of these things to be reshuffled a lot for the next few years.
No, I mean, ultimately, it seems like if you agree that modularity is a right architecture to kind of think about it, it effectively does become ubiquitous, and that's what you want, because what matters is how you communicate between two endpoints. Everything else gets black box abstracted away, and that's a great thing. And it gets even better and faster over time. I do want to kind of wrap things up. One interesting kind of theme here is that, well, we just said it's going to get even better and easier 5 years from now, but you've been here for 10 years in this space, 7 for you, around the same for me. Why are you still building in this space? What keeps you excited? What are things that kind of make you still want to push this ecosystem forward? And what can we kind of inspire everybody else here to do and think about?
It's a good question. So look, technology revolutions take a while to implement and diffuse. So the web gets a lot of, people tend to think of the web as starting in the 90s and then being kind of fleshed out by 95 or 97 or something like that. But in reality, all the hypertext work was decades before. A lot of the early versions of things like the web happened many, many years before.
There's
the web.
I was going to say, there's an interesting stat that most people don't know. TCP/IP was 15 years old in 1986.
Yeah, exactly. So, yeah, before the web, there was the internet, right? The web is not the internet.
The ARPANET, that TCP/IP. Yeah.
So technology revolutions take a long time. The cloud itself took like 25 years. So whenever you go into building that next paradigm for where technology is going to go, expect it to take a while to install and develop. So one of the pieces that keeps me around is just seeing the level of potential in this field for reshaping all of our civilization. So that sounds like a lot, and I do mean it to be a lot here. The economic primitives that we're playing with are superpowers. You get to rewire and restructure how all of society operates. Think of the Bitcoin blockchain. By just releasing one incentive structure into the world, it created the largest scale financial structure that wasn't put up by a government in history. So in thousands of years, nobody had ever built something of that magnitude, just run by a set of participants in the network with no authority, with no government whatsoever, with no violence behind it, just a single monetary system for the world booted up by one incentive structure. And then second, one of the largest consumers of energy on the planet, right? This is the bad part. Like, it's wasting an enormous amount of energy, and like that's a mistake. But it shows you how powerful one single incentive structure can be. And so if you design incentive structures correctly, you can move mountains. You can change the world dramatically. And so that level of power and capability could be used to build drastically better economies, drastically better societies, much better infrastructure for the world. And so it's that potential that I find super, super exciting. Kind of looking ahead to the next 10 years, I think that blockchains only need to get about 2 or 3 orders of magnitude larger in value to then be able to start funding science and technology at the scale of nation states. So when you think of the R&D budget of something like the US, it's in the scale of like 60 to 70 billion dollars a year, which is a lot, but it's not enormous. Blockchains could actually get to funding science and technology at the scale of the US within something like 10 to 20 years if they continue scaling at this degree. And so if we build the right public goods infrastructure and the right public goods primitives today, we could get to having a much, much brighter future worldwide.
Yep, same here. Like, I mean, I sometimes like, posted a very cheesy tweet also that, Web 3.0 is humanity 3.0 because, in terms of our rights and freedom, it's basically a completely new paradigm. Like, recently, like Harvard Business School did a case study on Polygon, invited me and things like that. And somebody asked me from the audience that every big technology reduces the cost of something like automobiles reduce the cost of transportation and steam engine before that, and now AI is doing the cost of intelligence and whatnot. And what does blockchain reduce the cost of fundamentally? And I thought for few minutes that what exactly is, like, because this was a big question for me to solve. And I realized that at the end of the day, if you see even BTC or anything else, like we say in simple terms, like it reduces the cost of trust, it reduces the cost of providing freedom to the people, right? To me, I think it's all about like freedom. It reduces the cost of freedom in any kind of environment, whether it's an app, which is right now, if you have a social app, which is run by one single person, that person can be good or bad, and you are always playing. Even the banks are run by one single institution, and you are always playing in their hands. You don't have like inherent freedom especially in the digital world. And in that digital world, like now we are spending more and more amount of our times and our lives into digital world, like 50 to 60%, 70%, maybe some people even more than that are spending in digital world. And we absolutely need these basic paradigms of freedom, property rights, everything on digital, and blockchain is that technology. That's why it's like very, very fundamental. And as Yuan was saying, like, see, even AI, like, I remember growing up in India, and we used to have this, like, I think it was a British or American show which was broadcasted in India called Small Wonder, right? Where there is a little girl, Vicky is the AI, right? And this is like 1995 or something. And that time also people were thinking about this like AGI kind of primitives, and see, like, only in 2022, which is 27 years from now, you actually are seeing some semblance. Even now, it's like nowhere near AGI, but some semblance.
Crazy part is GPT-3 was released 12 months ago, right? It's like it's not even.
Yeah. So it's insane. So that's why, like, a lot of people ask us that where is blockchain going? Why there is nothing even in 15 years like at that much impact? We actually, if we consider compared to other technologies, we have like multiple $1 billion worth of DeFi and decentralized finance markets already up on Ethereum by this time, and there are like multiple other things also are growing. So I think we are doing well, and hopefully in 10 more years we'll be at some.
Plus, we have like an entire infrastructure where you can now send money anywhere globally without ever having to ask anyone for permission. Like, that's a big fucking deal. Like the fact that you can have this entire financial infrastructure just run by computers online is crazy. The fact that we managed to build that is incredible. Now, on top of that, you can build way better systems, way better economies, way better societies, and so on. And that's what the next 10, 15 years are going to be about.
Optimism all around. I think this is a perfect way to end this. Thank you so much for sharing your amazing perspectives, and we'll be catching up again.